Hello, and welcome to the Green Ninja Climate Science series. This is going to be a series of about 10 or 11 videos discussing kind of the basics of the science behind global warming and climate change. My name is Patrick Brown. I'm a PhD student studying climate change, and I'm an alumni of the master's program at San Jose State University in the Department of Meteorology and Climate Science. And so these videos are going to be asking just some basic questions about some of the fundamentals of climate science. And so this first one we're going to start out with is a very basic question. It's just what would cause the Earth's temperature to change? So when we hear the term global warming, we are obviously talking about a scenario where the Earth's temperature is increasing. And so I just want to ask the very basic question of what would cause the Earth's temperature to change in general, in either direction. So first of all, we have to discuss, what is temperature to begin with? I mean, we all have a pretty intuitive understanding of the difference between hot and cold, and we know that we have these things called thermometers that give us an objective measure of how hot or how cold it is. But what temperature really is, fundamentally, is it's a measure of how fast the molecules of, in this case, air, are moving. And so when molecules are moving faster, then we subjectively feel that as the air being hotter. And so you may remember from like a physics class or something that when things are moving faster, that tends to mean that they have more energy in them. So I'm going to kind of answer the question right away. How do you get a change in temperature? You have to change how much energy is in the system that you're talking about. And particularly, you have to look at the energy budget, or how much energy is coming into the system versus how much energy is leaving the system. So if you have more energy coming in than leaving, then you have an imbalance in your energy budget, and you're going to have more energy accumulating in your system, and that's going to be manifested in an increase in temperature. And then, the opposite is true as well. If you have more energy leaving your system than coming in, then you're losing energy, and so that's going to be manifested in a decrease in temperature. And this is true for basically any object. It's not just the Earth, but it's definitely true for the Earth as well. So you may notice that this term energy budget, this energy in versus energy out, may be a little bit abstract, but when we kind of think about it, this word budget is used all the time in day-to-day language, and the energy budget is actually kind of totally analogous to the way that we usually use the word budget, which could be like with a country's government, like a government national budget, or with a family budget. So just to kind of put this in more concrete terms, we can think of a family budget, a family of four, let's say. And let's say the family has a total wealth of $100,000. And let's say that our family is, so this $100,000 is analogous to the temperature, let's say, in the actual energy budget. And so let's say that our family has some income and has some spending, right? And so let's say that they make $300 a day. They have $300 coming in. So this is like your energy in the energy budget. And let's say that they are spending $300 a day. So this is like the energy out term in our energy budget or energy balance. And so what's going to happen as the days progress, let's say? So after one day, well, nothing has happened to the family's wealth, nothing has happened to the temperature because we have the same amount of energy coming in as leaving. So the wealth stays exactly the same. And this is true after 2 days and after 3 days, etc. So when we have the same amount of money coming in as leaving, then we don't have a change in wealth. And so if we have the same amount of energy coming in as leaving, then we don't have a change in temperature. So now there are a couple ways to change the family's wealth in this case. You could increase the amount of money coming in. So let's say now they're making $400 a month, and they're still spending a day, and they're still spending only $300 a day. So what happens after the days progress? Well, after 1 day, the family has accumulated an extra $100. After 2 days, $200. After 3 days, $300. So you can increase temperature by increasing energy in and keeping energy out constant. But what's the other way? The other way that you could increase temperature, let's reset this back to $100,000. The other way that you could increase temperature or increase the amount of money that you have in your family would be by decreasing the amount of money that you're spending. So let's say that the family now only spends $200 a day and is still making $300 a day. We have the same difference of $100 every single day. So after one day, the family has accumulated an extra $100. After 2 days, $200. After 3 days, $300. So in the analogy back to temperature, we can get an increase in temperature by decreasing the amount of energy leaving the system and keeping what's coming in constant. So when we're talking about the real Earth system, let's just imagine that this down here is the Earth, and then we have the atmosphere, and then up here is space. The energy coming in comes from the sun. It's light from the sun. And a certain portion of that energy is reflected back to space, both from the atmosphere and from the land surface itself. But over here on the left side, this is basically our energy coming in. And then our energy leaving is in the form of infrared radiation that we'll talk more about in the next couple videos. But this is basically what the Earth's temperature relies on. It's how much energy is coming in from the sun versus how much is leaving in the form of infrared radiation. And we'll talk more about that and how that relates to current concerns about global warming in the next couple of videos.